We live in an age that worships velocity. We measure progress by the speed at which we can move information or the sheer force required to escape our own gravity. The ultimate expression of this faith was Apollo, a titanic, singular impulse designed to break the cosmic tether. Yet, there is a ghost in the machine of modern history. It is the physics claim that whispers the journey was not merely difficult, but impossible. For those who doubt the official narrative of the moon landing, the evidence lies not in grainy photographs or waving flags, but in the immutable, chilling language of numbers. They speak of radiation that should have sterilized the astronauts, thrust that should have pulverized the lunar dust, and a re-entry corridor so narrow it defied statistical probability. But let us pause the calculation. Let us ask, why does this particular achievement, one rooted in physics, feel so wrong to a part of the modern consciousness? The answer lies beneath the surface of the Earth, in the great silence of forgotten epochs. Geologists confirm the possibility of the Silurian hypothesis that massive, technologically advanced civilizations could have existed 300 million years ago, used up their resources, and vanished, leaving behind nothing identifiable as a ruin. If human history is but a fleeting moment, a tiny wave in an ocean of time, then the capability required for the moon mission becomes an unsustainable anomaly. The physics claims of the skeptics are not mere calculations. They are symptoms of a deeper geological paranoia. They reflect an intuitive understanding that technology, no matter how powerful, is always temporary. The universe, vast and indifferent, seems to enforce a rule. The price of high civilization is rapid obsolescence. If the very laws of physics made the moon landing a statistical improbability in 1969, what chance did any pre-dinosaur civilization have of conquering space? And if they failed, their failure defines the limits of our own existence. We are about to examine the impossible physics of Apollo, not to confirm or deny the event, but to understand why the numbers themselves amplify our greatest existential fear. That genius is perishable and that the cosmos insists on forgetting.
Chapter 1. The Instantaneous Summit. The single greatest hurdle in space travel is the concept of delta V, the change in velocity. It is the measure of the energy required to go from being a stationary object on Earth's surface to a free-moving object in space. To leave Earth's gravity well and then the moon's, an immense sustained force is required. Skeptics fixate on the paradox of the lunar module, the frail, angular craft that landed on the moon.
They point specifically to the ascent stage, the tiny capsule designed to launch two men from the moon's surface back into lunar orbit to rendezvous with the command module. The question is precise. How could that small two-man engine, fueled by relatively small tanks of hypergolic propellant, generate the necessary instantaneous impulse to achieve lunar orbital velocity, approximately 1.68 bir $? Visual, schematic of the lunar module ascent stage, looking fragile and tiny. They argue the ascent stage compared to the colossal Saturn V booster looks mathematically inadequate, a vehicle incapable of achieving escape. The physics, they claim, feels fundamentally disproportionate to the task. This doubt about the lunar module's capability becomes a powerful narrative device when measured against the deep history of Earth. We are asked to believe that the technology existed in 1969 to generate and control this impossible impulse with hand-soldered wires and basic computers. Now, project this technological peak backward 200 million years. The geological record shows that life has risen to stunning complexities multiple times. What if, during the Triassic period, a reptilian intelligence achieved a similar technological peak? What if they engineered materials capable of far greater specific impulse than our chemical rockets? The difference is not in the science, it is in the maintenance. The Saturn V was only possible because of a transient, government-funded singularity of engineering talent, resources, and singular focus. That level of capability cannot be sustained. We stopped building the Saturn V after a few missions, and the capability was quickly forgotten. To the skeptic, the impossibility of the lunar module achieving orbit lies not in the equation F may, but in the equation of historical stability. The moment of Apollo appears as a glitch, an exception that breaks the natural rule of regression. If we acknowledge the probability that Earth hosts a cyclical history of advanced civilizations, then the impossible physics of Apollo become a test case. If we cannot reconcile the physics of our own temporary achievement, how can we ever hope to prove the physics of an achievement that dissolved into the Earth's mantle millions of years ago? The physics of Apollo feels impossible because it defies the geological law of technological oblivion. It stands as a defiant monument against the fact that nothing, especially high-level capability, is permanent. The core doubt is not about the numbers, but about the terrifying certainty that we, too, are bound to forget how to fly. The unseen scar. Exhaust and regolith. One of the most visually persuasive arguments deployed by the skepticism community centers on the lunar module's LM landing. The logic is simple and powerful. A powerful rocket engine descending onto a soft, dusty surface should have created a massive blast crater, or at the very least, scoured the area beneath the engine bell clean of fine regolith. Yet photographs show the LM resting gently on the surface, with minimal disturbance directly beneath the main engine. There is no deep pit, and even the famous footprint photographs show dust undisturbed just inches from the descent pads. The official scientific explanation addresses this by referencing the physics of the vacuum environment and the throttling capability of the descent engine. The engine was throttled down significantly upon approach, and the exhausted gases expanded rapidly in the vacuum, preventing the high-velocity column of air, which creates blast effects on Earth, from forming. Essentially, the force was diffuse, not focused. Visual, side-by-side comparison. A jet engine blasting sand on Earth versus the LM on the moon with minimal disturbance. But the skeptic insists on the physical evidence or lack thereof. They demand a deep, undeniable scar. This demand for a scar is where the skepticism intersects most elegantly with the philosophy of deep time and the concept of geological memory. The skeptic is demanding a technological trace fossil. Geologists study trace fossils, or ichnofossils, the imprints, tracks, and burrows left by ancient life. A dinosaur footprint is a trace fossil. A worm burrow is a trace fossil. These subtle, non-body artifacts are often the only evidence we have of specific biological activity millions of years ago. The LM blast crater, had it been immense, would have been an unmistakable technological trace fossil, the signature of a brief, violent technological event. The fact that the physical scar is so subtle, so ambiguous, reinforces the skeptic's intuitive distrust in the permanence of action. Project this subtlety into the deep past. If the high-powered descent of a 1960s rocket leaves a barely noticeable disturbance on the airless moon, what evidence would the launch of a Permian civilization rocket leave behind on Earth? On Earth, we have wind, water, and biological activity, all working ceaselessly to erase surface detail. Any subtle depression or thermal scar left by a pre-dinosaur launch would be completely gone within decades, submerged under sediment, eroded by rain, or colonized by microbial mats. The Earth is allergic to definitive scars. The argument that the LM landing lacks a deep crater mirrors the archaeological riddle of finding definitive proof of technological prehistory. We are looking for grand, unmistakable monuments, but Earth's geological processes reduce even the most violent events to subtle, interpretable noise. The impossibility is not the lack of a crater, but the expectation that a massive technological act should leave a permanent, undeniable mark. The universe and the moon teach us otherwise. They teach us that even the most powerful impulses leave only the most transient of scars. If we struggle to locate the minute evidence of an event only 50 years past, how can we be certain of the absolute nullity of technological traces from epochs we cannot even comprehend? The universe insists that high technology, like life itself, must return to dust. The ballistics of forgetting. The journey home, known as trans-Earth injection, demanded a second act of impossible precision. Having successfully rendezvoused and docked with the orbiting command module, the astronauts faced the final terrifying ballet of physics, re-entry into Earth's atmosphere. Skeptics emphasize the minuscule size of the re-entry corridor. the narrow band of atmosphere that allowed the command module to slow down without either burning up or skipping off the denser layers back into space. The corridor was estimated to be only about 40 nautical miles wide. Deviate too much, and the result was catastrophic. Achieving this statistical near impossibility relied on the guidance computer, the Apollo Guidance Computer, AGC, a marvel of 1960s engineering. Yet skeptics question how such a small, limited machine, operating with just 2 kilobytes of core memory, could maintain the minute, continuous calculations required to hold the capsule on such a razor's edge. They call this a statistical impossibility, a defiance of chance. We must accept that mathematically, the feat was borderline miraculous. But this miracle, when viewed through the lens of forgotten civilizations, ceases to be a singular event and becomes a recurring theme in the deep history of high-technology societies. The skepticism of the re-entry corridor is, at its heart, a distrust of sustained capability. The true difficulty of the mission was not the initial blast-off, but the 4 years of continuous, error-free intellectual effort by thousands of engineers to ensure every piece of code, every trajectory, and every calculation was flawless. That level of prolonged, near-perfect concentration is the true anomaly in human history. If we accept the possibility of pre-dinosaur civilizations, we must accept that their peaks of intellectual prowess must have been equally, if not more, profound. Imagine a civilization in the late Cretaceous that mastered the control of gravity itself. Their ability to manage atmospheric re-entry would have been mathematically trivial. Yet, when their complex society collapsed, when their institutions dissolved, and their knowledge was left unmaintained, that specific sustained capability vanished completely. The physical skepticism over the re-entry corridor is a recognition of the impossibility of maintenance. The miracle of Apollo was that we held the statistical dice in our hands and prevented them from falling for 4 years. But time always claims its due. The moment the Apollo program was shut down, that capability, that sustained genius, began to decay. We did not lose the hardware. We lost the human ecosystem that made the hardware possible. To the skeptics, the very difficulty of the re-entry corridor suggests that the only way to achieve such a feat is by removing the element of human error and chance, implying a controlled environment or studio. But the philosophical reading is richer. The physics claims remind us that genius is ephemeral. The challenge of the re-entry corridor is an elegant demonstration of the universal law of historical regression. Any civilization, no matter how powerful its technology, eventually tires. It loses focus. It forgets the fine tolerances that separate success from incineration. The skeptics are simply pointing out the fragility of the moment, a fragility that ultimately governs the rise and fall of every technologically advanced species on Earth, from the Carboniferous period to the space age. The paradox of the void. In the cold, airless expanse of the lunar environment, physics operates without the comforting noise of our atmosphere. On the moon, there is no dispersion of light, no scattering of rays, no diffused sky, only stark geometric certainty. This very certainty, however, is what fuels a significant current of skepticism concerning the Apollo photography. Skeptics frequently cite the physics of the vacuum environment. Why do shadows appear to diverge? Why are the astronauts brightly lit when they are standing in shadow? Why do the photos lack the stars one would expect to see in the absolute blackness of space? Visual, a series of Apollo photographs demonstrating the waving flag effect and the brightly lit astronaut in shadow. These claims are often addressed by the physics of photography. The short exposure times necessary for capturing the brightly lit surface obscure the dimmer stars, and the uneven lunar surface causes shadows to diverge. Yet, the persistent doubt reveals a deeper narrative discomfort with the environment itself. The paradox is this. The moon, being the ultimate vacuum, should offer the clearest, most unambiguous visual evidence. Instead, the images yield the most subjective and hotly debated results. The absence of atmosphere appears to magnify doubt, not clarity. This is the psychological effect of confronting the void. Our brains are evolved for Earth's diffused light, where shadows are soft and air softens edges. When faced with the uncompromising contrast of the lunar vacuum, our intuitive understanding of light and shadow breaks down. We question the veracity of the image because it violates our learned terrestrial physics. Now connect this violation of intuitive physics to the concept of preservation over deep time. The moon is the ultimate preservative environment. If a highly advanced pre-dinosaur civilization had sent probes or settled the moon, their artifacts would remain perfectly intact, free from terrestrial erosion or decay. We would not debate the integrity of their flag or the sharpness of their shadows. Their ruins would be perfectly preserved but visually alien. If we struggle to achieve consensus on the photographs taken 50 years ago by our own species, how could we ever interpret the ruins of a civilization that viewed the cosmos through an entirely different biological or technological lens? The physics skepticism surrounding the photos is essentially a crisis of trust in visual evidence when stripped of all atmospheric context. It highlights the disturbing possibility that the more objective the environment, the less believable the evidence becomes to the subjective, terrestrial observer. This links back directly to the theme of forgotten epochs. The silence of the moon, the lack of atmospheric wind, water, or sound, preserves everything, but it also renders everything alien. If an artifact of a Carboniferous civilization were found on the moon, it would look so out of place, so perfectly preserved, that our first instinct would be to declare it a hoax, a fabrication, or an impossible physics claim. The moon, the ultimate witness, shows us that absolute certainty is impossible. The physics of the void dictates that evidence, no matter how perfectly preserved, must always pass through the subjective lens of a mind rooted in a terrestrial past. The skeptical claims are a cry against this fundamental epistemological gap, the terrifying realization that the ultimate truth may look so strange that we can only call it a lie. The velocity of doubt. Finally, we arrive at the heart of the matter, where the rigorous claims of physics intersect with the profound resignation of philosophy. The core arguments of the moon landing skeptics, the unaccounted for thrust, the lack of a blast crater, the narrow re-entry corridor, the ambiguous light in the vacuum, all coalesce into one single, coherent, existential fear: that we are not the masters of our domain. These impossible physics claims are simply the modern language used to describe the law of historical regression. The universe maintains equilibrium by ensuring that extreme technological capability is always temporary. The very energy and precision required for Apollo, the sustained excellence necessary to navigate that narrow re-entry corridor or achieve that precise orbital impulse, were anomalies that broke the natural cycle of human incompetence and entropy. We question the veracity of the moon landing because it is the linchpin of our conviction that we have permanently transcended our history. To question Apollo is to admit the possibility that we are just another wave that has crested and is now receding. The physics skepticism thus becomes a profound act of acceptance. It is a surrender to the idea that the laws of nature are absolute, and technology is merely a temporary, fleeting defiance. If the laws of probability and physics made the Apollo missions a near impossibility 50 years ago, then the existence of a high-technology civilization before the dinosaurs, a civilization that left no trace and faced the exact same physical constraints, is a statistical impossibility that must be seriously considered. The ultimate paradox of proof and memory remains. We cannot affirm absolute certainty about our own recent history when the Earth itself has erased the existence of others who may have faced, and failed, the very same impossible physics. The moon landing, whether real or staged, functions as a powerful narrative device. It forces us to confront the fact that our greatest achievements are written in volatile code and thin aluminum, while Earth's deep history is written in the solid, indifferent rock that recycles all evidence. Let us close this journey not with certainty, but with wonder. We are the inheritors of a world that has forgotten itself countless times. We walk upon the petrified silence of forgotten epochs that may have achieved their own impossible ascents, only to be swallowed by the deep time. The doubt surrounding the moon landing is merely the faint echo of that ancient geological oblivion. If you believe that the deepest truths lie hidden beneath the obvious answers, and if you are ready to reconsider what you know about the history of this planet, please share this video with others who understand the power of analytical doubt. And do not forget to subscribe, for the cycle of forgetting has many more mysteries to reveal. The velocity of our doubt is the speed at which we approach the profound truth. that we are not the first, and the silence of the deep past is the only permanent thing in the universe.